Hi everyone, this is Sharif Sami. Today's main topic is about solving system of linear equations. Before we start, I prefer you pause the video and read the question first. To start the solution process, we rearrange the equations in a certain manner to look like a function. That is, one of the unknowns would be a function of the other two. So for x1, we pick the equation that has the highest coefficient of x1, and then we rearrange it like this. And in our case, we use the third equation because it has the highest coefficient of 8. Likewise, for x2, it's either the first or the second equation, as we already have used the third one. And in this case, it is the first equation that has the highest coefficient of x2. This leaves us for the second equation for x3. For the first iteration, we start by assuming initial values for x1, x2, and x3, and the simplest approach is to assume that they are all zeros unless otherwise specified in the problem. These zeros can be substituted into x1 to calculate its new value. Then, we substitute this new value of x1 along with the previous guess of 0 for x3 into x2 to calculate its new value. And by now, we can use the new values of x1 and x2 to compute x3. By the end of this iteration, the new values of the unknowns are the following. We have here the x1 has a value of 2.5, x2 is 7.167 approximately, and x3 is negative 2.76. These new values would be the old ones for the next iteration. And we'll repeat the calculations again to get the new values. And in this iteration, we can calculate the approximate error for each unknown. And just to remind you, we stop when we meet the stopping criteria, when all of the errors are less than 5%. And luckily for us, in this problem, we meet this criteria after only 3 iterations. For the case of relaxation, the only difference here is that we modify the new values as follows. We get x1 as we did before, which is 2.5, and then we substitute in this equation, that is the new value of x1 times lambda, that is 2.5 times 1.2, plus 1 minus lambda, that is negative 0.2, times the old value of x1, which is 0. So the new value of x1 is 3. And we do the same for x2 and for x3, and we end up with these new values after this iteration. Put in mind that lambda is an empirical value, and it will be given in this problem. We can notice that we reached the stopping criteria after 6 iterations. So in this problem, the value of relaxation retarded the convergence, and that was meant to show you what would happen if you assumed lambda random. Alright, this concludes our tutorial, so until next time.